Welcome to part 4, the deaths model class. So just as we did above with the cases model class, we're going to create a deaths model class to model the deaths of each area. So for this to work, we're going to need the lag, which is the number of days between the cases and deaths, and the period, which is the number of days to tabulate the total cases or deaths for the CFR calculation. So once we have this CFR, we're going to predict new deaths by multiplying that number, the CFR, by the number of cases that happened lag days ago. So here's a concrete example. Say we want to predict the number of deaths on November 6th. We look back at the number of cases on October 22nd, which is a lag of 15. We're going to multiply the number of cases by this CFR for that particular area, and that'll get us a prediction, and then we'll do a little bit of smoothing to just smooth out the results. So here's the actual code for the deaths model, and it does take more than just the lag and the period. So I'm going to talk about those other parameters here. So it's going to take in the data, which is a dictionary of those 4 data frames for USA cases, USA deaths, world cases, and world deaths. The last date for training. It's going to take an instance of the cases model, and this is after the run method has been called. So we're going to use some of that information from the cases model here. And then of course it takes the lag and the period. So in the constructor, it will set these arguments as attributes. And then it has these dictionaries to hold the results. So one for the daily predicted deaths, one for the cumulative predicted deaths, and then one for the combined actual and predictions of daily and cumulative. So it has that same method over here, get last date, in case the input for last date is none, so it'll just use the very last date available. So we saw that in the cases model class. We also have this method now, calculate CFR, which we just talked about in a previous video, which calculates the CFR for every area. And then importantly, we have this run method, and that will do all the heavy lifting. And we have some just one method like we did before to combine the data of actual and predicted into one data frame, and then another plot prediction method. So if you notice, the deaths model class is much less code than the cases model class, because we're not doing, the model is just very simple. It's simply a multiplication of the CFR times some cases lag days ago. Okay, so let's look at this run method that's doing all of our heavy lifting for us. So the first thing that happens is we're going to calculate the CFR. It'll be stored in this attribute, CFR. So it's just a dictionary of data frames, one for each USA and for the world, with the CFR for each. And so what we'll do is we'll go through each of the 2 groups. There's just 2 groups. This is just getting the keys ready to grab the data. So it'll be either USA cases or world cases. Same thing here, USA deaths or world deaths. Okay, so this is a date that is going to be 15 days before the last date. So this will be the beginning of when this will be the first day that will be used for the prediction. So we're going to multiply the value here of cases times the CFR to get the very first predicted value into the future. So that's what we're going to do here. We're going to take the last date that we have training data for, and we're going to subtract 15 days or whatever the lag is. So that'll be that day, 15 days before the last date. Now, here's where we use our cases model. So we're going to get the smooth cases. So we're going to use the smooth cases, so it'll be a little bit nicer, not the actual data, but the smooth cases. So we're going to get that for the whatever particular group we're in right now. So say we're on USA cases, so we'll get the USA daily cases smoothed, that data frame. And we're going to filter it just for the days, all the days, and this is the combined daily, so it has actual and prediction. So we're going to use the predicted values of the cases into the future. So not just the 15 last days, but the 15 previous days plus all the days into the future. And that's why we created this combined daily in the first place, is that so that we could easily make predictions for deaths into the future without having to, go back and forth between two data frames. So we're going to use one data frame here, which has actual data and predicted all in the same. So we get that over here, this daily case is smooth. And we're going to look at from 15 days before the last date all the way to the end. So we did model 50 days into the future. So this should be 15 plus 50, about 65 days right here of cases. And then we're going to multiply this by the CFR of the current group. So every area in here will be multiplied by the number of cases, and we will get this daily prediction. And the prediction will be, so this will give us, for all 65 days. But if we want the prediction, the number of predictions just to line up with the number of cases, then we will cap it by whatever the number of predictions we used in the cases. So that's why here we see cm.n predict. So whatever we use for the cases model for the number of predictions, we will also use for the deaths model. Okay, so we're actually just we're gonna change the index here. So because of this shifting 15 days to the left, our daily predictions for cases, for deaths, we want to align with cases. So we just use the index for cases like that. And the last step here, like I said before, is we're going to smooth the data. We just do this repeated rolling average. So we're just going to loop over here. We just set it to 5 times. This will make it nice and smooth. We're going to do a 14-day moving average and just find the mean of that. So this is just a smoothing. It's not 100% necessary, but it makes it look a little bit nicer as in the result. We're going to round it and then convert it to an integer here. And then we're going to store the results. So this is where we store the results in this predict daily attribute. So this is actually part of the instance itself. So each one will get stored over there. And so that's for the daily. To get the cumulative, we need to get the very last cumulative value. So we get that. This is from the actual data. Right? So we look at the actual data. We look at the very last date of it. We'll store that to a variable named last deaths. So we'll just take the cumulative sum of the daily for the predicted and then add that to the last deaths. And that will be stored into the predict cumulative attribute. All right, so that's basically it. The last thing is to call this method, which just combines the actual and predicted. So we talked about that before in the cases, but that's what it does. It just combines the actual with the prediction into a single data frame. And then we have another method to plot the prediction. All right, so that is it for the explanation of the DeathsModel class.